Example 2, another dividing problem. This time though, we have a few problems to deal with, and we'll check these off up in our steps. Before we try to do division, write the dividend and divisor in descending powers of the variable. And what that means here is we've got x cubed, but we're going to look at part 2 here, insert placeholders with the 0 coefficients. We don't have any x squareds. So we need to say 0 x squareds. It's just a placeholder for the x squareds to make sure that we have a spot for every single type of x. X squared, all the way up to x cubed, and then we do have a minus 1 at the end. We're dividing by x minus 1. If we have it set up properly like that, we're just going to divide just like we did in the prior example. X goes into x cubed, x squared times. Notice that since we have the placeholder, we can put x squared on top of x squared. Multiplying back out, x cubed minus x squared. Careful with your negatives. When we minus a negative, we get positive x squared. Bring down the 0x as a placeholder. X goes into x squared one time. What happens when you minus a negative? You get a positive. X goes into x one time, and x times negative 1 is negative 1. We don't have any remainders left, and so our answer is x squared plus x plus 1. See if you can do it for yourself. Here is our answer. X minus 3 goes into x cubed plus 0x squared plus 0x minus 27. X goes into x cubed, x squared times. We'll have x cubed minus 3x squared. When we subtract, we get 3x squared minus a negative. We'll bring down the 0x. X goes into 3x squared, 3x times. 3x times x is 3x squared. 3x times negative 3 is minus 9x. Minus a negative is positive 9x. We'll bring down the 27. And x goes into 9x 9 times. And negative 3 times 9 is negative 27. And so it does work out with a remainder of 0, which means we did the problem correctly. X squared plus 3x plus 9 is our answer.